Good morning. I'm Rob Sin, and here I'll turn my computer a little bit so the backlighting behind me doesn't wash everything out. So, yes, I'm going to be the instructor for college geometry. The course is online. I'm recording here from my office in Newton Oaks. So, even though the course is online, I am available many days during the work week, many times, and you're welcome to come in and visit. And I plan to offer an introductory video, give you ideas about what assignments are coming, what the course involves, and also to get you started on a couple of things you need to be doing right now. But first things first, we will not use a textbook. Our course notes are online and the URL is there. It's also in our D2L course. And let me show you what we've got. Okay, this is the homepage for our geometry course, and we are going to be starting with foundations and finite geometries. Okay, and notice that the sections of the chapter are all listed over here, and we have neutral geometry, Euclidean geometry, and also we have some help files down here. Right, so we have our axiom sets, which we'll need at various times, LaTeX or $math for geometry. And also there's a lot of help for geometry projects. There will be a final project at the end of this course. So the online notes are pretty extensive and they're also very helpful. So you'll want to check those out. Let's jump back in here and talk about the assessments. How am I going to get an A, right? What is graded? Well, we're going to have two what would normally be in-class tests. This class alternates. One year it's offered in class, the next year it's offered online. That helps for our master's degree teaching students who often have a full-time job. It makes the course more accessible. And instead, it used to be offered at night every other year. Now we offer it every other year online. So there'll be two tests. Those will be in D2L using the Respondus Lockdown browser. We'll have quizzes. There'll be at least one every 2 weeks. We do have a Teams proof project. You will be assigned to a team in D2L, and your team will put together proofs, which I will grade. But then the nice thing is they'll be graded, there'll be feedback on them, and hopefully they'll be pretty much correct. Why? Because then you'll have 50 or 60 proofs in D2L that your team has done and gotten correct that you can use as study aids for the tests and the final exam. We do have a project, and I showed you in our in our course, right? So we do have, and there are extensive help files or pages and lots of project ideas. So we'll talk more about that when it comes. The final project will be due probably the Sunday night before exams. I try to give you as much time as I can to work on it, but then again, I do have to grade them all and get grades turned in. So having them due during finals week isn't so optimal since y'all need to take your finals. So we'll probably have it due right before finals week, okay? So, and there will be a final exam also in the Respondus Lockdown browser. So you're going to be using a laptop or a desktop computer. You've got to make sure that it does have a microphone and camera because it records you while you're taking the test. Okay, so what do we need to be working on right now? So in D2L, it's called Module 0, and it covers two things. LaTeX, which is also a lot of times online, you'll hear it called $math. It's an equation editor that was created decades ago, but it's still what all mathematicians use for their journal articles. It's still the best equation editor out there. And we'll talk about GeoGebra. Now, a couple of things that are cool about LaTeX and GeoGebra is that D2L has a LaTeX-enabled equation editor, and so does GeoGebra. Okay, and so what we're going to do with Module 0 is we're going to learn about GeoGebra and LaTeX. Why? So we can create these dynamic GeoGebra proofs. Okay, and I'm going to show you one that proves the triangle inequality. The triangle inequality is pretty straightforward. It says that the length of the sides of any two sides of a triangle are greater than the length of the third side. And this is true it's a strict inequality as long as we have an actual triangle. If the three vertices of the triangle are collinear, then we need a less or a greater than or equal to if it's a degenerate triangle. So you sometimes see when we use the triangle inequality in other areas of mathematics, like differential equations or real analysis, they'll use a greater than or equal to rather than a strict inequality. And I did link to the proof. Why? Because you're going to create a geometry, a GeoGebra um, profile, right? And it's free, right? You'll sign up for it and it'll look something like this. And so this is actually inside my area of the of GeoGebra. Let me just show you. You can see it's got me. And what are we doing? This is some of the editing area, as you'll know, because you've probably used GeoGebra before. But here's what I mean by a dynamic GeoGebra proof. And let's make sure this is running. Okay, sorry, it has updated since my computer accessed it. So here is a statement of the triangle inequality. For any triangle ABC, we have A plus B, AB plus BC is greater than AC. So when I use this notation, AB, in geometry, that means the distance between points A and B. And of course, in Euclidean geometry, that's a straight line, right? But so we write, line segment AB, but the length of line segment AB is just AB, all right? So we're saying that the distance from A to B plus the distance from B to C is greater than the distance from A to C. And the proof is fairly straightforward. Let me get rid of some of this extra stuff. So this is what I mean by dynamic geometry proof. Did you notice how the triangle appeared and the text appeared? So let there exist an arbitrary triangle ABC. And just for the moment, we're assuming that the longest side is AC. If the longest side isn't AC, I can just relabel the triangle, right? If the longest side happened to be AB, I can just swap the two vertices B and C, relabel the triangle. And so this is just to make our proof very general. So if we do need to, we can relabel the triangle, and that's not really specified. But you'll see why we need that longest side in just a moment. So we're going to extend one of the shorter sides of the triangle, AB. We're going to extend it to a point D in such a way that these 3 points, A, B, and D, are collinear, and that the distance BD is equal to the distance BC. Now we're using the ruler postulate to accomplish this. That's our warrant. Okay, so every theorem statement, you have a statement and you have a justification, right? And my justification here is the ruler postulate. We'll go over those more in depth in later videos. And then I'm going to create the line segment CB and CD, right? So we've got both of these now, right? And they have equal lengths, right? Why? Because the way we created this, right? Let me just point out that the way we created it, BD is equal to BC. So we know that these two sides, these two line segments are congruent. So we know that this triangle, BCD, is isosceles, right? It has two side lengths which are equal. All right, let me get rid of some of the mess. There we go. And the next step in the theorem, now that we know that it's an isosceles triangle, after we create this line segment CD, we have a triangle that's isosceles. And then we know that this length AD is equal to AB plus BC. So that's interesting, right? So this whole length AD is equal to the length AB plus the length BC, which is the triangle inequality. That's what we want to prove. We've just added this ancillary line here to make this whole big line segment available. Why? Well, you'll see that because this angle is interior, this angle is, well, since B is interior to angle ACD, we know that AD is greater than AC. All right, we know that this whole length AD is greater than this length AC. Why? Well, because this segment B, right, is interior. And maybe I should have said C. But right, if I look at this big angle, let me get rid of a lot of the mess here. Right, so if I'm looking at this big angle, right, this ray, BC, is interior to this big angle, which we know is a line, so it's has measure 180 degrees, and we know that this angle, right, this smaller angle here, ABC, has a smaller measure because this ray from B to C is interior to the big angle. Okay, so we know that AD is greater than AC. So we know that this big distance from A to D is bigger than this smaller distance from A to C. And then we are almost done, right? If we just use substitution, what is AD equal to? Well, that's why we created this isosceles triangle, because AD is equal to AB plus BC, which gets substituted right in here, which therefore is greater than AC. And so by substitution, the triangle inequality is true. Now, what do we mean by what do I mean when I say we'll be creating dynamic GeoGebra proofs? Okay, this is what we're going to do. We're going to create them so that they appear as we need them to, right? We're going to learn how to create these checkboxes in GeoGebra, checkboxes, and they'll have text that appears when you check the box. But you can also set different pieces of the figure to show up when we check the boxes. So that's how the figure is growing and changing so that the new things we need to see are available on the drawing as we go. So that's a dynamic GeoGebra proof, okay? And you will be creating them. Why? Well, there's a couple of things that are great about it, but the major reason we'll be using these is because we can post them, we can post links to them from D2L. So we can be posting in a discussion list on D2L and post a link to a GeoGebra proof. And then the cool thing is we can update the proof. If there happen to be a typo or a mistake in the proof, we can just fix it in GeoGebra and the link is still correct, and then the proof gets corrected. So we can it makes life really easy in geometry class to learn how to do these dynamic GeoGebra proofs and to create a free account at GeoGebra that will allow you to save your drawings and post links to them. And again, we're going to be using these LaTeX equations. It's also called $ math a lot of places on the internet. So we're going to use LaTeX to enter our equations, both in our D2L discussion threads, and we'll use it. It displays a little better sometimes in GeoGebra. Okay, and we do have a help page for LaTeX in our online courses, in our online notes for the course, right? So $ math for geometry. And I just want to point out that if I want to create this measured angle, right, I can click right here. You see the copy pops up when I put the cursor over the top right area of the triangle. It will copy, and if I left click on that, it will put it, it will do an edit copy of the code that I need, and then I can use edit paste in D2L or whatever, or in GeoGebra. So there's lots of help for you guys on how to do that. Sorry, I went back to the drawing. I meant to come here. So I created a discussion thread, and one of your jobs, one of your assignments over the weekend should be to get a Geogebra account. It's free. Create your Geogebra account and create a drawing according to the specifications, and which just means you have to create a polygon. Um, so create a polygon and then link to it in the D2L discussion thread. It is for a grade. I do need you to do that for a grade. And why? Let me just explain that. I don't usually like a my way or the highway approach, but I've tried to get students in the past to create the online GeoGebra account, and several students each semester refuse to do it, even though I offer extra credit for it. Um, and so now I'm going to offer actual credit for it. Why? Well, it just really helps with our proofs projects, our team's proofs projects, and also the ability to get help on a proof. Um, a lot of times it's really hard to get online help for a proof, but if we have GeoGebra, if the proof is in GeoGebra, I can look at the first half of the proof and give help. Okay, so it's just I'm just going to require it this semester, um, because 100% of my students did not voluntarily get an account before, even though they're free. Um, so course outline people have been asking, and I do plan to put a course calendar up, and I apologize this wasn't done sooner. Tuesday was a tough day to create online content. Um, so we're going to start off in finite geometries, and this is basically going to be a review of your Math 2800, your Intro to Proofs experience, but tailored more to finite geometries. The key thing in finite geometries is that confuses folks is the definition of parallel. And let me just draw, right? These are parallel lines in finite geometry. Why? Because they do not intersect. Parallel doesn't mean two straight lines that are equidistant, everywhere equidistant. I know that's the feel that we have in Euclidean geometry, but that's not the definition. The definition of parallel lines is that they do not intersect. Okay. Neutral geometry will come next. What is neutral geometry? Neutral geometry is starting down the pathway to Euclidean geometry, but not assuming a parallel postulate. Okay, so we prove everything we can in Euclidean geometry without a parallel postulate. And we'll do that for a few weeks. It turns out we can prove quite a bit, but we do run into this roadblock. We can't finish Euclidean geometry proofs content until we actually assume what's called the Playfair postulate, which is the Euclidean parallel condition. Analytic geometry, that's when we use equations we use algebra, for example, prove something is a right triangle. How could I do that? Well, I could use the distance formula algebraically to get the distance between the two legs and the distance of the two legs, the length of those line segments and the length of the hypotenuse line segment. And then I could apply the Pythagorean theorem, or I could find the slopes of the legs and see if they had that perpendicular relationship. So that's analytic geometry, where I start using algebra and equations. And also analytic trigonometry is analytic geometry. Non-Euclidean geometry, we probably won't do too much with this. Again, there are some crazy things like the parallel lines that just look a little odd in non-Euclidean geometry, and we'll talk about that as we go, but there won't be that much non-Euclidean geometry. And I want to mention that this is a theorem proving course. So on our quizzes and our tests, the final project, our exam, there will be theorems that you will be asked to prove. Now, most of the hard ones I have done proofs for, and I will show them in the videos and link to them in our course. What do I mean by a hard proof? Well, sometimes a proof has ancillary lines that are hard to guess, like which lines you need to draw so that you have the things you need. Like in that triangle inequality, knowing how to do that proof, it's not a hard proof, but you have to know, oh, I have to extend one of the shorter two sides of the triangle to create this isosceles triangle. And then, the argument works, the argument goes through. So again, many of the proofs are not hard. And when there are these little tricks, you draw this line here and this line here, and then this is equal to this, when it has some tricks that aren't easy to see, I go ahead and prove those for the class. The other proofs are not that difficult, but they are often different than a lot of students have seen. Um, so it does take a couple weeks to get used to it, but the proofs part of this course is honestly not that hard, um, especially in Euclidean geometry. Proofs in Euclidean geometry, they are pretty straightforward. They have a sort of they have just a few ways that they go, and you learn those few ways to prove things, and then you do it over and over and over. So it's a it's a class that emphasizes a few important topics, a few important types of proofs, and then we do those proofs over and over. So again, welcome to my course. Thank you so much if you're still watching, and I will have more content posted for you, and I will try to get on a more routine schedule of posting content on Tuesdays and Thursdays. Get to work on Module 0, get to work on your Geogebra account, free online Geogebra account, get to work on learning some $ mathematics, also known as LaTeX. And there are assignments posted. They're mostly discussion post assignments, an introduction, and the link to your first GeoGebra drawing in your online account. And get that done, and I will talk to you soon.